Okay, students, now we are going to study electrostatic potential energy and electrostatic potential. Okay, so far we have been discussing the electric effects in terms of a vector quantity called electric field intensity, okay, which was E vector. And electric field intensity is nothing but force experienced by a unit positive charge. Okay, so earlier what we were doing, we were talking about electrical effects in terms of vector quantities like electric field intensity, like Coulomb's force. But right now, what we are going to study, we are going to study a new concept where we will be studying electrical effects in terms of a scalar quantity called electrostatic potential. It is represented by V. But what is the importance of studying this electrostatic potential? Why we have just incorporated it in our study of electrostatics? See, the reason to this is to answer the flow of charge. We know that charges always flow from one charged body. See, if this is a charged body and this is a neutral body, then we know that charges flow from the charged body to the neutral body, isn't it? Of course, yes. So, and what else? We also know that if this is a positively charged body, this is again a positively charged body, even then the charges flow in between them. So, the question is, what determines the flow of charge? The question is, in which direction the charge will flow? What is decided by that? And the third question is, how long will the charge flow? So, all these questions are answered by the study of electrostatic potential. Electrostatic potential is a quantity which tells us the degree of electrification of a body. ये आपको पता होगा कि if a body is charged, तो it means it is able to exert an electrical force on the other body. Okay, correct? So, if a body is charged and it is able to exert electrical force, तो it means वो electrified है. लेकिन कितना electrified है? Okay, that is answered by this quantity. The object which is more electrified is said to have more potential. The object which is less electrified is said to have less potential. This is point number one. That potential, why we are studying? Because it decides the electrification of a body. कि कितना electric force लगाने के capable है. Point number two, it decides the flow of charge, direction of flow of charge. Which means किस direction में charge flow होगा. We often say that charge flows from the body which is at higher potential to the body which is at lower potential. Okay, so this is also decided by V. And next thing is, V is a scalar quantity. So a scalar quantity to represent all our views about electrostatics. Is it clear? So this decides basically the flow of charge. So now we will be studying in details how we should get to this. Before that, we will be studying electrostatic potential energy. Suppose you have a charge here. This is plus Q charge here. ये source charge है. If this is a charge over here, that means it is creating an electric field around it, isn't it? So this is a charge, it is creating electric field around it. So suppose I am taking this position of charge as my origin, so that this is the x-axis, this is the y-axis, and this is the z-axis. And of course the region around this charge is nothing but electric field. ठीक है, अभी यहाँ पर आपने टेस्ट चार्ज रख दिया है प्लस क्यू. ठीक है. So this plus q charge would naturally be repelled by this positive source charge, isn't it? Of course, yes. So when this positive charge will be repelled by this source charge, so the natural tendency, the natural force will be here, will be directed here. But suppose you are deliberately taking this charge from here and you are entering it inside the इलेक्ट्रिक फील्ड. देखिए, अब नेचुरल टेंडेंसी तो रिपेल करने का था, बट आपने डेलिबरेट फोर्स लगाकर इसे उसके इलेक्ट्रिक फील्ड में एंटर करवा दिया. ओके, इन दैट केस, don't you think that you have done some work against the electric field? Of course, yes. You have done some work against the electric field. So, don't you think that the work that you have done will be stored in this charge in the form of its potential energy? And that potential energy is nothing but electrostatic potential energy. Let's have a look here. Suppose you are carrying it forward deliberately against the electric field. Okay, you have kept it here and you are holding it. But एक बात का आपको यहाँ पर you have to keep in mind कि आपको सिर्फ उतना ही फोर्स अप्लाई करना है जो कि इसका इलेक्ट्रिक फोर्स बैलेंस कर सके. See, the electric force is repulsive. Clear? So you have to apply only that much force which can balance this electric field. You need not to apply excessive force. Okay, why am I saying this? Because if you do that, if you are applying just the balancing force, then that means net force is equals to 0, which means the object is moving without acceleration. ओके, नेट, बिकॉज आप जो फोर्स लगा रहे हो वो इलेक्ट्रिक फोर्स से बैलेंस हो रहा है, तो नेट फोर्स इज इक्वल्स टू 0. सो m इंटू ए इज इक्वल्स टू 0, which means acceleration is 0, which means charge would be moving but it won't be accelerating. Okay, that you have to keep in mind in order to steadily study these electrostatic effects. Okay, so सपोज दिस इज पोजीशन ए, दिस इज पोजीशन बी. अभी होगा क्या? इफ यू वॉन्ट टू ब्रिंग दिस चार्ज टू पोजीशन ए and you have kept it here holding it, then different amount of potential energy will be stored. If you have moved this charge to position B, then different amount of energy will be stored, isn't it? So let's figure out the work done from A to B. Work done from A to B. So to move the charge from A to B, you are doing some work against the electric field, and that will be integral of F external vector dot dr vector, where dr vector जो है वो displacement है AB की. Okay, this AB is dr vector, which means it is the displacement. We know that work done is equals to the dot product of force and displacement. Clear? So this is WAB. I'm again writing the equation for you. F external vector dot dr vector. Clear? Now, what is going to happen over here? That this external force is, equal and opposite to the electrical force. Electrical force कौन सा था? जो naturally लग रहा था, repulsive force. So this external force is balancing this electrical repulsive force. That's why this charge is moving, isn't it? So in place of this F external vector, I can write minus electrical force, because they both are equal and opposite. Minus electrical force dot dr vector. Okay, so this work done is stored in the charge in the form of its potential energy. Okay, so next is WAB. So WAB is UB minus UA. Let's have a look how I have written this equation. तो ये तो हो गया आपके पास कि if you have brought the charge from A to B, तो उसका potential energy increase हो गया. But ये potential energy के difference की बात हो रही है यहाँ पे. We are talking about the difference in potential energy. What if I am talking about the potential energy at position A only, and what if I am talking about the potential energy at the position B only? So how can we go about it? Suppose this was my source charge, okay, and this is position A. You are talking about the potential energy of plus Q at this point A. So सपोज करो आप इन्फिनिटी से चार्ज लाते हो. इन्फिनिटी इज दैट area over here, is that position over here where electrical influence of this charge is not reaching. ठीक है, यहां तक कोई इलेक्ट्रिकल इन्फ्लुएंस इसका नहीं जा रहा है, यहां तक इसकी इलेक्ट्रिक फील्ड खत्म हो जाती है. ठीक है, सो दैट इज इन्फिनिटी. Okay, so suppose this is infinity and the electrical influence of this charge is not reaching up there. That area we are calling as infinity. Now suppose if you bring plus Q charge from infinity to this point A. So आप infinity से चलते चलते इस चार्ज को लेकर आ रहे हो, तो don't you think earlier you were at no electric field zone, but now when you are taking it here, you are entering in the electric field zone. So don't you think all of a sudden this charge would refuse to go straight towards this charge, because repulsion start हो जाएगी वहाँ पे. All right, so whatever force you are applying is actually counterbalancing the repulsive force, isn't it? And suppose करो no electric field zone से you are bringing that charge and you're keeping it here. So some amount of work that you have done to bring it towards here, that will be stored in the form of potential energy, and that is the potential energy of point A. If you want to define the potential energy of single points like A, B, you have to take the charge from infinity. If you want to discuss the potential energy difference between A and B, तो आपको सिर्फ A से B तक लाना होगा. Clear? And you know कि B का potential energy ज़्यादा होगा. क्यों? Because the charge which is closer to the source charge, उस तक लेकर आने में ज़्यादा वर्क होता है, ज़्यादा रिपल्शन ओवरकम करनी पड़ती है. मोर द वर्क दैट यू हैव डन, मोर द पोटेंशियल एनर्जी विल बी स्टोर्ड इन द बॉडी. ट्राई टू गेट इट. ओके, सो पोटेंशियल एनर्जी ऑफ पॉइंट बी इज मोर देन द पोटेंशियल एनर्जी ऑफ पॉइंट ए. अब पोटेंशियल एनर्जी ऑफ पॉइंट बी विल बी यू बी, वो इन्फिनिटी से आया है सिंगल पॉइंट का, एंड पोटेंशियल एनर्जी ऑफ पॉइंट ए विल बी यू ए. एंड नाउ व्हेन यू आर टेकिंग द ऑब्जेक्ट फ्रॉम ए टू बी, so what you're doing, you are increasing the potential energy of the object by how much amount? UB minus UA. So this is potential energy and potential energy concept. This is potential energy difference. Clear?